All right, we're going to start proving some trig identities. Make sure you copy these down. I'm going to need these here in a second. We got sine, cosine, tangent, cosecant, secant, and cotangent. Make sure you scribble these down as well. Tangent, we've already talked about being sine over cosine, and cotangent is just the reciprocal of that. It is cosine over sine. Pythagorean identities, we talked about sine squared plus cosine squared equals 1. We talked about that with a unit circle because we said x squared plus y squared equals 1 was our unit circle. And cosine being the x, sine being the y. This is kind of like saying y squared plus x squared equals 1. Here in a second, we're going to do some proofs, and you need to be able to kind of think outside the box as far as knowing that different things can equal different things at different times. So tangent squared, and sometimes it can equal sine squared over cosine squared. Tangent squared can sometimes equal 1 over cotangent squared. Sometimes it can be secant squared minus 1. You can rewrite tangent squared as tangent times tangent. So this is the notation there. Tangent squared is equal to tangent there. So let's look at a few of these. First one. So I give you the answer down at the bottom to make sure that you simplified it to the correct thing. So I got cosine of x times tangent of x. I know that I can rewrite tangent of x as sine over cosine. And at this point, I can multiply these. I notice that I have a cosine on top and a cosine on the bottom, so I can zap those two things, and I'm left with just sine of x, which is what my answer is down there at the bottom. Next one. Similarly, cotangent is equal to cosine of x over sine of x times secant of x. I can rewrite that as 1 over cosine of x. And I can zap that with that. And I'm left with 1 over sine of x. That's not my answer, though. But I do know that 1 over sine of x, if I go back to my reciprocal identities, is equal to cosecant of x. All right. I'm going to multiply a little bit here. Several different ways you could go about this. Several different ways. I'm just going to do one of these ways. Secant of x. Let's rewrite that as 1 over cosine of x. You could rewrite sine over cosine. So we could change tangent of x to sine over cosine if we wanted to. So I could change that to sine over cosine and then flip this, sine over cosine down here. I'm not going to do all that. I'm going to kind of separate this fraction out. Like if I have 3/5, that's the same as saying 3 times 1/5. So I'm going to rewrite this as sine of x times 1 over tangent of x. And there's several different ways I could go about this now, but I'm going to rewrite the 1 over tangent of x as cotangent of x. So that's cotangent of x. And it's up top. And I know that cotangent of x is equal to cosine over sine. So I'm going to have 1 over cosine of x times sine of x times cosine over sine. Then I can start canceling some stuff out. Like that zaps with that zaps with that. All of that would reduce to 1. Next one. I've got tangent squared times cosecant times sine, and we have to make it say tangent. All right. Well, let's rewrite this tangent squared as sine squared of x over cosine squared of x times cosecant is 1 over sine. And then let's leave this cosine right there. And so this sine squared, cosine squared, I could write that as this if I wanted to. I could write that as sine of x times sine of x over cosine of x times cosine of x. That's what that first term means over there. That sine squared plus cosine squared, you just multiply it. So I could cancel this sine squared with like one of these sine squareds. Then I cancel this cosine with one of these cosines right here. So that leaves me with sine of x over cosine of x, which is tangent of x. Next, I got cosine squared of x times secant squared of x minus 1. I know that secant squared of x minus 1, if I look at my Pythagorean identities, that second one over there, it says tangent squared of x plus 1 equals secant squared of x. So if I were to just subtract this 1 over here, I've got tangent squared of x equals secant squared of x minus 1. Okay? So this is right here. So I could substitute tangent squared of x in for that. So I've got cosine squared of x times tangent squared of x. And tangent squared of x, I could rewrite that as sine over cosine. And then I can zap that with that, and I'm left with sine squared of x. How about you push pause real quick, try this one. The cosecant squared of x, that's the same as 1 over sine squared of x. 1 minus cosine squared of x is sine squared of x. That goes back to our sine squared plus cosine squared equals 1. I could subtract the cosine squared over there and have sine squared of x equals 1 minus cosine squared. So taking that sine, plugging it in over there. And that zaps with that. That leaves us with 1 left over. Okay, how about you try this one? This one's pretty straightforward too. I got cosine of x times, I think this is secant squared of x. So that would be cosine of x times 1 over cosine squared. So that zaps with one of these. So I'm left with 1 over cosine of x, which is just secant of x. All right, I got sine of x over cotangent squared of x plus 1. The first thing that I'm noticing is that cotangent squared of x plus 1. And when I look at my Pythagorean identities, I see that same thing. 1 plus cotangent squared of x equals cosecant squared of x. So this is equal to sine of x, and then that's going to be cosecant squared of x. And I know that there's a couple different ways you go about this. We're going to keep change flip just to practice that. I've got um, sine of x, keep, change, and then flip. So I'm going to flip that's going to be 1 over cosecant squared of x now. And I know that 1 over cosecant squared of x is equal to sine squared of x, which would be sine cubed of x. Okay. The thought process from this step to this step can vary. Just a little bit ago we said we did the 3/5. So 3 times 1/5. It's the same thing here. I took the sine of x and then the 1 over. I just kind of separated the fractions. So keep, change, flip, separating them similar. Okay. Simplify this one. First thing I'm noticing is 1 minus sine squared of x. I know that's cosine squared of x. So I'm going to have cosine squared of x over. I know that this is a Pythagorean identity, and it is cotangent squared. Okay, so we can separate that fraction if you want to call it that, or you can keep, change, flip. I've got cosine squared of x times 1 over cotangent squared of x. And I'm going to leave the cosine squared. I'm going to kind of get that cotangent squared in terms of sine and cosine. So if you haven't really noticed already, most of these I'm getting in terms of sine and cosine and then seeing what I can zap. So I've got cosine squared of x times 1 over cotangent is the same as tangent. And then this is cosine squared times sine squared over cosine squared. And then that zaps with that, and I'm left with sine squared of x.